Hey guys, Mr. Bowman here. Today's learning objective is in blue and we are learning to simultaneously, I'm going to underline that, simultaneously calculate the mean and standard deviation in an inverse normal distribution question. And what it means by simultaneously calculate, it actually refers to questions where you don't know either of the mean or the standard deviation. So you're trying to find both of them at the same time. I thought the best way to illustrate this skill was through an example, and I've got that in the blue box on the bottom left, and I'll read that out loud. So Mr. Bowman's Year 11 Extension class had some mixed results in last year's exam. The top 10%, I'm going to underline that, the top 10% got over 85%. However, the bottom 15% failed the exam, i.e. below 50%. If the tests were normally distributed, calculate the mean and standard deviation of Mr. Bowman's Year 11 Extension class. I'm just going to underline the question, calculate the mean and standard deviations. Because we are looking for both, that suggests it is a type of question where we simultaneously need to solve for both the mean and the standard deviation. So I'm going to write a bit of a checklist as we go. So step 1, we need to draw graphs of, I'm going to underline it, of both groups. So during the question, I underlined something about the top 10% and the top 15%. We're going to draw separate graphs for both of those groups. So there's our first normal distribution curve, and that relates, circling the question now, that relates to the top 10%. So let's do this. And that area on the right tail, the top 10%, would be 0.1. And we now need to draw another graph with the second group, and I'm circling that on the screen as well, and that's the bottom 15%. And that had an area of 0.15. After that, we then add in the other bits of information we know. So regarding the top percent, we know they got over 85%. So the X value relates to 85. And we know the bottom 15%, they failed, so they got 50% or below. The things we normally put in, we'll normally put in the mean just over here, but we don't know what that is. And we'll also put the mean over there. We again don't know what that is. And typically we'll put the standard deviation up on the top right. But we don't know what either of those are either. And that is step 1. So we basically mapped out what information we have, what information we don't have. The next step is we are looking to calculate the Z value for both graphs. And what that means is 485, 450, we are trying to find out what is the equivalent Z value, or how many standard deviations are those numbers away from their means. And to do this, we actually need to draw another graph. So there's our normal distribution curve, not a very good one. And there's our second one. So we need to convert our first graph and our second graph into what we called standard normal distribution curves. And that is where the mean, so the mean is always going to be equal to 0. And the standard deviations, they're both going to be equal to 1. We're then going to use the inverse normal function calculator to find the respective z values. So the next bit of information we can put in is we can put in the area that we know about. So that one was 0.1 and that one there was 0.15. Actually, I'm going to move that away from the bottom. Let's move that to the top. And we then need to calculate the z value. And that tells you how many standard deviations away from the mean is that shaded area. And that's really important. So when you're using the z values, we're going to be using the inverse normal function on our calculators. And we'll be able to put in the area of 0.1. We know it's a right tail, and we know the mean is 1 and the standard deviation. So the mean is 0 and the standard deviation is 1. If you put that into your graphics calculator, you would have got z is equal to 1.2816. There will be a video in the link below that describes how to convert this type of graph to a inverse normal question if you are having issues with a skill. The next one, we have a left tail, we have an area of 0.15, we have a standard deviation of 1 and a mean of 0. If we use our inverse function, we'll be able to calculate what the z value is. And this one here is negative 0.364. And both of those are rounded to 4 decimal points. Once we've got the z values, we now are looking to set up our z formula equations. So set up z formula equations. And just like we've been dealing with a graph for each group, so this one related to 0.1s, these ones related to the 0.15s, we also need to set up an equation for both of them separately. So for the first one, z is always going to be equal to x minus the mean divided by the standard deviation. We know that the z value was equal to 1.2815. Oh, sorry about the pen there, had a bit of a glitch. That is always going to be equal to x, so x related to the 85% from the initial graph, minus the mean divided by the standard deviation. We're then looking just to do a little bit of algebra to rearrange this. So we've got it divided by standard deviation on the right-hand side. Let's move that to the left and make it multiplication. And finally, let's move that standard deviation, or that mean, that minus the mean, to the right-hand side. So because that's minus, that becomes a plus. And I'm going to get you to leave it in that form. We want the standard deviation with the mean equaling to a number on the other side. And we can use our graphics calculator to help us at that point. We then need to do the same on the right-hand side, or the bottom 15% portion. So we're going to write down our formula. Our z value was negative 1.0364, and that was going to be equal to x, which is 50%, minus the mean divided by the standard deviation. Like we did for the other one, we do need to do a bit of algebra. So negative 0.364 standard deviation. So that divided by standard deviation becomes times. That is going to be equal to 50 minus mu. And we're then going to take the minus mean over to the other side and make it a plus mean. So negative 0.364 times the standard deviation plus the mean is equal to 50. And you can see at this step, both of the equations look similar. We have the standard deviation on the left-hand side for both. One's positive, one's negative. We have a plus mean on both sides, and the right-hand side is just the respective x value, or the number that's left over by itself. Once we've done that, our final step is using the simultaneous equation solver. Oh, that's not how we spell simultaneous equation. So simultaneous equation solver to find the standard deviation and the mean. And the way the graphics calculator works, it's a bit unique, and in the link below there is another video that describes it, but what you've been asked to do is you've been asked to identify A. Apologies about that. You've been asked to identify A, which in our case relates to the standard deviation, 1.2816. You've then been able to identify B, which is 1, because there's one standard deviation or one mean, and then you've been asked to identify the number on the other side. We now need to do the same for the next equation, negative 1.0364. We then need to put the mean. Again, there's only one mean there. And finally, we need to identify the C, or the number on the right-hand side. When you put that into your equation, or your simultaneous equation solver, just going to move my answer up here. It is going to tell you that X is equal to our standard deviation, and that was 15.1%. And secondly, it's going to tell you what Y is equal to, and Y represents our mean, and that is going to tell you it's equal to 65.65%. And the first one was rounded to 1 dp, and the second number was rounded to 2 decimal points. And that is the answer to our question. We've been asked to calculate the mean and standard deviation of Mr. Bowman's Year 11 Extension class. We had a standard deviation of 15.1%, and our mean score was 65.65%. Hopefully you found this video useful. Just a reminder, there are 2 videos in the description below that helps us with the graphics calculator side of these videos. They will help you with how to convert your equations into A, B, and C, to use the simultaneous solver function to calculate the mean and the standard deviation. And they're also going to tell you how to calculate the Z value using the inverse normal distribution calculator. All right, so this was a video on the longer side, but hopefully you found it useful. Best of luck for this type of question.